We've seen how well our model performs quantitatively by plotting the loss curves and evaluating it here with the test accuracy metric. But now let's do one of the most fun things in machine learning, and that is make predictions on the test data and even some custom data. So make some predictions on images from the test set. And there's a few things we have to keep in mind when we're making predictions on images or on any kind of custom data. Do you recall what they are? And it's okay if you don't, that's why we're going through this again. So let's adhere to the Data Explorer's motto of visualize, visualize, visualize. And make some qualitative predictions on our test set. Let's write down some things to keep in mind when making predictions / inference on test data / custom data. This comes all down to formatting. So we have to make sure that our test / custom data is the same shape. So images need to be same shape as model was trained on. Of course, you can vary the shape. You could make them smaller, you could make them larger, but to get similar performance to how your model went during training, you have to make sure your data is in the same shape. And then we need the same data type. So custom data should be in the same data type. What else is there? We need the same device. So custom data / test data should be on the same device as the model. We've seen all of these errors before: shape errors, data type errors, device errors. There's one more that we've gone through in this notebook, and that is, what did we do? Right up here, we created transforms for our images. So this is kind of the same shape and same data type, but I'm going to put it here as an extra one as well. Same transform. If you've transformed your custom data, ideally you will transform the test data and custom data the same. Now, of course, these are all come with an asterisk. You don't necessarily have to do all of this, but to prevent errors and to ensure you get similar performance as to what's been printed out here, you'd like to go through all of these steps for your test and custom data. So how about we create a function to do all of this magically? Let's create a function called pred and plot image. Now we've done a similar function to this back here. Yeah, there we go. This is section 4. Putting custom image prediction together, building a function. We're going to use a very similar function to this, but with a few tweak steps, just for some practice. So I'm going to put this in here. We'll go here. The function will be similar to the one here. So you can go read that if you'd like. But let's start with step number 1. We want to take in a trained model. We'll start with a model. Take in a trained model, a list of class names because we want to map our model's predictions to the class names, a file path to a target image, an image size for how much we should format the image, and a transform and a target device. So that means we're just taking care of all of these shape, data type, device, transform steps. Particularly transform will take care of most of them. Then what do we want to do? So 2 is open the image. We need to open the image. Open the image with, let's use pill this time. Pill image.open. Step number 3, we want to create a transform if one doesn't exist, because we want to make sure our images are transformed by default. And then 4, we want to make sure No typos here, Daniel, come on. Make sure the model is on the target device, very important. That's going to take care of this one here, same device. We'll have to subsequently also make sure the data is on the same device, won't we? And then we want to turn the model to, we want model.eval mode to make sure it's ready for inference. This will turn off things like NN dropout gets turned off during inference. And recall, you can find out what is dropout by going like this. What is dropout? There is plenty of different resources for that. It's mainly a regularization layer to prevent overfitting. Then we will go, we want to transform the target image and make sure its dimensionality is suited for the model. This mainly relates to batch size. We want to make sure if we're passing in a single image, it has a batch size of 1. We can do that with the unsqueeze method. We're going to see all this in code. We're just typing out our steps here. Make a prediction on the image by passing it to the model. We'll do the forward pass. And then we want to convert the model's output logits to prediction probabilities. We can use torch softmax for that. Torch.softmax. We've seen this in the past. And number 9 is convert model's prediction probabilities to prediction labels using, what do we do here? We use torch.argmax because we want to take the prediction probability or the index where the prediction probability is the highest, and that is the model's predicted label. And then we want to plot the image with matplotlib because we want to get visual after all, don't we? And set the title to the prediction label from step 9. And for a little bit more, why don't we also add the prediction probability from step 8? Oh my goodness, this is going to be one full-on function, but I think rather than do it in this video, I'm going to issue you the challenge to try and create a function that goes through all of these steps. I think you can do it. And if you want a reference, we've done this in section 4, a very similar function here. 11.3, go and check that out. You can reference this function as much as you want, but try to go through these steps and see if you can get our model to make predictions on a random set of images from the test data. And we'll go through these steps in the next video. I'll see you there.